In a world where only smart people are allowed to understand, a chart that's been haunting classrooms for 150 years, You Don't Get Science presents the periodic table.
What cheap jump scare? Who thinks the periodic table is scary?
Well, the periodic table is only for geniuses, Pepper. We're going to talk about all of it today on You
Got Science!
Got Science! It's true that studying the periodic table can get complicated, but unless you decide to study chemistry further in high school or college, the part you really need to understand is actually really simple and so cool. You got science, here to make it fun.
Today we're in the kitchen to demonstrate.
Hello, I'm here. I heard you're finally going to do something in the kitchen.
My mother-in-law, everyone. Hi. Hi, Nana.
Look, here, I'm so excited.
Oh, Nana, you don't need to do that.
Oh, but wait a minute. You've got your iron with your silver.
Well, they're all forks in that column.
But these are columns, and columns are families, and families have to stay together.
Right. So you want to organize not based on forks, knives, and spoons, but by what material they're made of and where they would be on the periodic table?
Yes.
I love it!
See, metals are on the left of the periodic table, and non-metals are on the right.
Where did that come from?
The noble gases are on the right.
Right. Neon, argon, helium, they're in the far right column of the periodic table. Thank
Okay,
you.
There you go. Now you're perfect. And salt is sodium chloride, a compound. So we'll just put this away.
Nana, that's not table salt. That's pure sodium. It's for the classroom.
Oh dear. Oh.
It's always a good idea to have a fire blanket in the kitchen.
Sorry. Oh, what a mess. Oh. I think we need to do a little fix now.
What do I do with this?
Trash.
Wait, what? So that wasn't the compound sodium chloride that we use as table salt, was it? Did you see what happened to pure sodium when it got wet? That reaction wasn't random. Sodium lives in column 1 of the periodic table. Remember how Nana was talking about how these up and down columns are called families? Often, like human families, members will share certain characteristics. Every element in column 1 has just one valence electron, like we talked about back in our episode about atoms. Because of that, these tend to behave in the same way. They're especially reactive with water, other elements, and, the air. That's why we can predict how well they'll behave. Teachers might think they notice patterns in human families and adjust their seating charts accordingly. Up and down columns are families, but the side to side are called periods. Like you read a sentence and then there's a period. The atomic number increases and the properties change in a repeating pattern. That's why we call it the periodic table. Now let's read one square. Carbon. Every square on the periodic table tells us 3 things. The atomic number. The atomic number is how many protons the atom will have. It never changes. If it's 6, it's always carbon. It also has the symbol, the element shorthand, C for carbon, and the atomic mass. This is the total number of the protons and neutrons added together. It's written as an average because not every atom of an element will weigh exactly the same.
Here's a quiz for Mr. Fizz.
Let's find capitals.
Paris, Rome, Sacramento.
No, not capital cities. Capital letters. If you've been watching You Got Science, you know that H2O is a chemical formula. When you read a chemical formula left to right, every time you see a capital,
Send a postcard.
no, every time you see a capital, that means they're introducing a new atom in the equation. The little number that comes after the type of atom tells you how many of that atom is in this formula. Notice there's no number after O for oxygen. That means there's 1. Let's look at another one. Remember, every time we see a capital letter, that introduces a new type of atom in the molecule. Na is the symbol for sodium. Cl is the symbol for chlorine. That's 1 atom of sodium and 1 atom of chlorine, which makes sodium chloride or table salt. Use the periodic table to identify elements you don't recognize. Your turn.
1 carbon and 2 oxygens.
Yes, carbon dioxide. Plants love it. Last one.
That's a license plate.
Same rules.
Carbon 6, hydrogen 12, oxygen 6.
Exactly. And that's glucose, a type of sugar. And here's some candy as a reward for a perfect score.
Welcome to Traveling Periodically, where Mrs. Thicke visits the must-see highlights of the periodic table.
Non-metal National Park sits right in the top corner of the periodic table. Brittle solids, terrible at conducting heat or electricity, the perfect retreat from screen time. Bring a blanket and leave your devices. What? Not your thing? Try Metal City. It covers most of the left side. Huge, shiny, very busy metals conduct heat and electricity, so things heat up fast. Don't miss the metalloid staircase. This is the zigzag border between metals and non-metals, the metalloids. And they act like both, which makes them the perfect computer chips. Great view, excellent selfie spot. I got us in to the Noble Lounge. It's here you'll see celebrities like Helium and Neon. They don't interact with anyone, not like me. I love your work. I love your work. Thanks for touring with me. Next time we'll visit Hawaii. Oh, I mean hydrogen. The non-metal that is an island far away from the other non-metals.
And now it's time for Let's Get Real Deep for a Minute.
Scientists could not see atoms when they organized the periodic table over a century ago. We still can't see individual atoms without really advanced imaging technology. Atoms are just way too small, so they didn't see them. Scientists watched how material behaved when the same behaviors kept showing up as properties of matter. They realized that there had to be structure underneath. This is why the periodic table is grouped by behavior and why it works every time. Atoms have certain behaviors, and the periodic table is here to show you the receipts.
This has been Let's Get Real Deep for a Minute.